Hi everyone, Terry here from Concord Concrete Pumps. Today we'll be continuing our series on technical support and maintenance. Before we get into that, we have an announcement for our customers. Concord will be opening a parts distribution warehouse here in Las Vegas. That means you'll be able to have parts shipped directly from the US, and that'll extend the cutoff times to 4:30 Pacific. So that should avoid any customs delays that might have occurred in the past. We're pretty excited about getting that ball rolling. Also, I will be offering a free ACPA 1-year membership with any new pumps ordered between now and World Concrete. Okay, so let's get on with it. Although this series of videos pertains mostly to Concord pumps, most of the pumps are very similar to this design. This episode will be on the accumulator circuit. The accumulator circuit tells us a lot about the operation of the pump, especially when you're having issues. So using this diagram, we'll go through the various systems and touch on the purpose of the various controls. Let's start with the oil tank. We must maintain proper oil levels. It's surprising how often I get calls from customers complaining that their accumulator pressure is low or their accumulator gauge is vibrating and they're getting a weird noise coming from their hydraulic pump. This is cavitation caused from either a dirty suction filter or low oil levels. Neither of these are a good thing. Make sure that your oil level is part of your daily routine. I personally recommend about 4 inches, 5 inches max from the top of the tank. This allows for sufficient oil expansion, and there are some manufacturers that their maximum oil level gauges are actually too low. I've seen this quite often when the pump is set up not perfectly level or the oil level is a bit low in the gauge and they still have cavitation. So it's best to go from the oil level to the top of the tank and allow yourself enough room for expansion. So this is a good time to mention the sediment bowl. Every pump will have one. So at the bottom of the tank, at the lowest part, there's going to be a sediment bowl which will catch water and sediment that settles in the tank. I recommend draining it until you see clean oil at least once a week for the first few weeks. You'll eventually get a routine and know when this needs to be done. Changes in temperature and dry cylinder packings may cause water to contaminate the hydraulic oil. I recommend you check your sediment bowl on a Monday morning. That gives your oil a chance to settle any sediment and water that may be in the system. I recently had a customer that told me that never happened to them. They never got water in their pumps. So I asked him if we could check on a few of them. So he took me to a pump that he recently bought about 10 months ago, and we checked it, and we found that he had about a half of a 5-gallon pail of water in his system. So he was pretty shocked, and now he makes this part of his routine. All pumps make condensation, so this should be checked. And also, there's going to be sediment from the welding procedure when the pump's built, little pieces of brass or steel or O-rings will all get caught quite often in the sediment bowl. So it's a good thing to check that. I would recommend every Monday morning for a little while until you'll get very, very little water coming out of it, so you can adjust how often you do it from that. The suction filter right here. Another common problem of cavitation is and premature pump failure is from a dirty suction filter. My personal recommendation is just change it once a year. That way it's easy to schedule. You don't have to do it by how many hours you pump, and then you have to determine when do you put the pump down to do the filters. Just change all of your filters on your pump once a year and you'll be in good shape. So the next thing we're going to look at is the accumulator pump itself. Oil enters the accumulator pump through the suction filter and then is pressurized to the accumulator bottle. And then there's actually a check valve here. and then it flows from there through a manual dump valve, and then onto the manifold, or as some people call it, the brain. One thing I want to mention, if you ever change an accumulator pump, make sure that you fill that through the case drain with hydraulic oil. This is the case drain going back to the tank. If you don't fill that, you will get into an argument with your parts guy, because if it doesn't get filled with oil, you will have a pump failure. You can be sure of that. So the next thing we're going to talk about in our circuit is the accumulator bottle. So the accumulator bottle is actually a hydraulic spring, if you would. It stores energy while the S-tube is not shifting over. What a lot of customers think, that if they accumulate, the nitrogen is low on your accumulator, that your S-tube won't shift. This is not true. Actually, what will happen is it'll shift slow. If you were to remove the accumulator bottle completely and cap it off, the S-tube will shift. It will just shift very slowly. The bottle itself is filled with nitrogen, and it's charged to 90 bar, about 1300 psi. Now, why do we use nitrogen? We use nitrogen because nitrogen does not expand as it heats up. There's a bladder inside here, a rubber bladder, and when it compresses that bladder and the S-tube is ready to shift, it will unload a fair amount of oil, and that's where the speed of this your shift cylinder comes from, not from the accumulator pump. The accumulator pump only charges this thing. And then, as I mentioned earlier, there is a check valve here, so that when that S-tube shifts over and uses all of that energy, the oil does not come back through and affect the accumulator pump. So here we have the manual dump valve. All Concord pumps have a manual dump valve installed. This can be used for testing or working on the pump, and this valve remains closed during normal operation. If you have to work on the pump for any reason, if you're working on the S-tube, shift cylinders, wear ring, wear plate, or you have to chip the hopper, this valve should be open, allowing the accumulator pressure to go back to the tank. In that case, the S-tube cannot shift over. Here we have an electric dump valve, which operates basically the same as a manual dump valve. This valve operates by depressing any of the emergency stop switches, and it's located on the manifold and is operated by a coil. It's good practice to check the operation of the dump valve on a regular basis to ensure that it's operating as it should. So this is a good opportunity to explain the operation of the accumulator gauge, which is very important. First, make sure that the gauge is operational. So if you don't have a good accumulator gauge, it's very difficult to diagnose problems with the pump and its performance. You can test the nitrogen pressure on an accumulator bottle. With the PTO on, watch the accumulator gauge and hit any emergency stop switch. The gauge should be at 190 bar and then slowly drop down to 90 bar. At 90 bar, the bag will be completely depressed and the gauge will drop to zero quickly. Whatever that gauge reads when it does that sudden drop is the static nitrogen pressure in the accumulator bottle. If it's low, it could be recharged and checked for leaks. If it leaks, obviously the bag or the complete bottle must be replaced. So now we're on to the manifold, or what's commonly referred to as the brain. This incorporates the electric dump valve, the 190 bar valve, the 70 bar valve, and the volume control. Oil flows through the dump valve and either goes back to the 190 bar relief valve or is dumped back to the tank in the e-stop position. 190 bar oil is now available to shift the S-tube over depending on the position of the four-way valve, and we'll get to that in a minute. So the 190 bar oil is further reduced at the 70 bar valve, which goes to the volume control, which goes on to the main hydraulic pump. So at 35 bar from the volume control, you will have no output on your volume. and at 0 bar, you'll have full volume through the regulator into the main hydraulic pump. The 4-way valve, and I know this is hard to see, is hydraulically operated spool valve, which gets a signal from the right side sensing valve mounted on the top and the bottom of the drive cylinders. The sensing valves receive a signal from the piston in the drive cylinders when it reaches either the top or the bottom of the stroke. This oil signal pushes the 4-way valve in either direction to switch the S tube and the direction of the drive cylinders through the large 4-way valve. So let's just sum things up again here. So here's your full hydraulic tank, nice clean oil, comes into your accumulator pump. A little bit of oil is going to go back to the tank through the case drain onto the accumulator bottle. And this is your nitrogen charge here. And then it's going to be pressurized on. There's your accumulator gauge. Make sure that's operational through the manual dump valve onto the electric dump valve, which is normally closed. Oil is going to go onto your 190 bar valve, and then onto your 70 bar reducing valve, and then onto the volume control. The volume control is going to go over to your governor on the top of your main hydraulic pump, operated between 0 and 35 bar. 0 being wide open, 35 will be full volume. Here we've got our 4-way valve, the small 4-way valve, which gets its signal from the drive cylinders. Either the top or the bottom of the sensing valves are going to send a signal over and push this 4-way valve back and forth. When this goes back and forth, the S tube will operate, and it also operates the big 4-way valve, which changes the direction of the cylinders. So here's your shift cylinders being controlled by the 4-way valve, and the big 4-way valve, which I don't have, it's mounted underneath the small 4-way valve, which controls the direction of your cylinders right here. And that pretty much sums it up. So here's kind of the heart of everything. This valve has to be closed. If this valve is defective, it will dump oil back to the tank and you'll have no accumulator pressure. If this valve is defective, it again will dump oil back to your hydraulic tank. And even the volume control, often if the volume control fails, it can dump oil back as well. And that's about it for the system. I hope it helps. I know, when you're on the job site and you have an issue, it's nice to be able to understand the system and see what to look for. Very, very important, that accumulator gauge. So pay close attention to that. Make sure it's operational. When you guys have a problem and you call us, that's one of the first questions we're going to ask you. Is it an e-stop? What's your accumulator gauge? And we'll be able to help you from there. So please feel free to give me a call at any time. My number is 801-564-1729. If you need any assistance, you can also reach Concord at 1-800-201-2223. And stay tuned for our next video. Thank you all, and be safe.